Hello class! So, the first part of this school year, we spent our time learning about the things that make up chemistry. The protons, neutrons, electrons, and things that make atoms into elements and compounds. But what we have to face is that these elements are hardly ever by themselves in nature. They're always reacting with something, and chemistry is all about these reactions. We want to know, why do certain elements bond together, and why did that reaction happen? So class, if you remember from our first week, an atom has a nucleus that contains protons and is surrounded by electrons. Protons have a positive charge and electrons have a negative charge. What makes an atom bond with other electrons is its valence electrons. Valence means its outer electrons. The number of valence electrons, you'll remember from class, is the same as the row number on the periodic table. This number tells us how many bonds we can make. We know that atoms want to have 8 valence electrons. If an atom doesn't have 8 electrons, it will fill the rest of its spots by making bonds with other atoms. A bond connects 2 electrons so that then 2 atoms are now connected. This is what constitutes a reaction. We can think of bonding like puzzle pieces. If it has only 2 spots, it can make 2 bonds. But if it has 4 spots, it can make 4 bonds. Let's look at a really common molecule, salt. It is made up of sodium and chlorine. Sodium only has 1 valence electron, while chlorine has 7. They will hook together just like puzzle pieces. One of the electrons from chlorine will connect with the 1 electron of sodium, making a bond of the 2 electrons. Now they share the 8 electrons. Sometimes elements will bond to each other, and sometimes they won't. But how can we tell if a reaction or a bond is going to happen? One of the first patterns we will learn in this class is called electronegativity. Yes, I know it's a big word, electronegativity, but let's break it down a little bit. What would you give to go to have lunch at your favorite restaurant right now? How much do you want money? How big is your desire to sleep and take a nap right now? Just like you want to eat, sleep, or make money, a want like that can be so huge you would do anything to get it. Electronegativity is kind of like this. Basically, it's how bad an atom wants more electrons, or more formally, how strong an atom's pull is on another atom. Electronegativity, or how strong an atom's pull is, increases as you go up and to the right of the periodic table, but we don't include the halogens. So, the most electronegative atom is fluorine. A bond will happen if one atom is stronger than the other. This kind of bond is called an ionic bond. And these kinds of bonds, we understand them better if we think of them like a ball at a sporting event. In an ionic bond, the more electronegative atom steals the electrons. So, let's review. Remember that atoms bond by using their valence or outer electrons, and they want 8 of them. And these electrons will hook together like puzzle pieces, making bonds to fill in the empty spots. And they will bond by electronegativity. Remember that electronegativity is how bad an atom wants more electrons. And if one atom is strong enough, this will create an ionic bond. The electronegativity tells us if a bond will happen. The ionic bond will tell us where the electrons are going and how the reaction is going to happen. Now, it's your job to be ready to recognize and identify these patterns of ionic bonding and electronegativity, especially since we'll be learning even more patterns in class this week.